Welcome to Mastering Solutions. In this general problem, they want us to find the average speed on the second leg. Let's write down the variables that they give us in the problem first, and they tell us that the total time that the person does the race in is 47 minutes and 25 seconds. The speeds that they give us, though, are in miles per hour, and that's what the final unit will be that we need to find for this speed right here. So to do that, I'm going to convert the time here into only hours. That way all the units agree and our math will come out correctly. So let's change this 25 seconds to minutes first. So we know in 1 minute there are 60 seconds. We have 25 divided by 60. So there is 0.416 minutes, and then we are going to add 47, of course. So we have 47.416. So the total time is 47.416 minutes. And now we're going to convert that into hours. And in 1 hour, there are 60 minutes, of course. So we'll take that and divide it by 60. So the total time is 0.79 hours. Let's put it over here, 0.79 hours. So now they tell us that the distance that he went uphill is 4.6 miles. And the velocity, we'll say velocity 1 for uphill, was 8.75 miles per hour. Downhill, the distance was, of course, 6.9 miles. And the velocity 2 for downhill, obviously, we don't know. That's what we're trying to solve for, miles per hour. So now let's write an equation to better visualize what we're doing conceptually. We know that the change in time for the whole race is equal to the time that it took to go up plus the time that it took to go down. So now we can use the velocity equation. Velocity obviously is a change in distance over a change in time. And then if we rearrange this, we'll move time over by multiplying both sides. That'll give us delta x is equal to v times t. And then we'll isolate t now by dividing by v. So if we come over here, delta t is equal to delta x divided by the velocity. So now we can plug this in up here. So the delta t total, actually let's move this over first, that'll be a little easier. So we're going to isolate the down since that holds what we're trying to solve for. So if we subtract the uphill time from both sides, t up, we have t total minus t up equals t down. And now let's plug this that we found right here into this. So the total time total minus the time for the up, which we said was delta x over v. So delta x for the up divided by the velocity of uphill is equal to the delta x down divided by the velocity down. So now we need to isolate this, the velocity for the going downhill. To do that, I'm not going to write it out, but essentially what we're going to do is we're going to multiply both sides of the equation by velocity going down. That cancels. We'll multiply all of this by that. So we'll have v d for down. And then we're going to divide both sides of the equation by this whole phrase right here. So now when we rewrite that, we will have isolated the velocity for the downhill section. Downhill is equal to the distance that we went going downhill divided by this whole phrase right here, which is delta t total minus delta x going up divided by velocity going up. So now we have our final equation to solve for the velocity that was for the downhill section. So now all that is left is to plug it in. So v down is equal to 6.9 miles, and that will be divided by the time total, which we said was 0.79 hours minus 4.6 miles for the uphill section divided by that velocity, which was 8.75 miles per hour. And so now as we put this into our calculator, we have 6.9 divided by 0.79 minus 4.6 divided by 8.75, and that gives us 26.108. So we'll round that to 26 miles per hour for the final answer for the velocity for the downhill section.